Yep. Hello, 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 hello. Test mic. Yep. Looking fine. So, hmm. Yeah, this will be mostly like a full learning of Go mainly. That is one thing. I'll be learning by this mostly. And yeah. So, firstly, what do I need? Right? Okay. So, yeah, I think it's better to do that. You open a new one. No. New. Um, uh, how to open a new? Reset canvas. Yeah, reset is also fine. So, firstly, I'll need the Go compiler. Oh shit. Um, Go compiler. Go comp. Then I'll mostly need like second. I'll need uh, a editor. Maybe VS Code. I'll use editor. I'll use VS Code. Um, yeah. I think that's currently all we need. So let's get started. Let's start with Go compiler. Uh, let's see. Download and install. Yep. So currently, do I have any Go compiler? No, I don't. Let's download. Yeah, I think. What is the one? Where is Windows? Let's think. I think this is it. Save here. Seems like okay. So I'm having like a huge amount of dropped frames. I don't know why, but yeah, we'll see about that. Okay. I have the Go compiler. Now let's delete. Uh, let's install. Next program Go. Okay, install. I'll go with all default. And the next I need is text editor. Oh, not this one. VS Code. Yeah. Okay. Should be fine. Yes. Download for Windows. When download, and one more AI setup. Code helper. Code helper, which is basically Codium, free AI code. Okay, I'll need this also, but after I install VS Code, that is. Let's see. Next, install. Okay, install. Uh, I hope this much is fine. So in the later parts, we will mostly also need like what a Docker maybe. We'll see about that, but yeah. Okay, I have Go and yeah. First, let's make this usable. Tokyo Night. Yeah, I think this is called Tokyo Night. Material. Oh shit. I need Tokyo Night. Tokyo Night. I need material UI. I think this is it. Is this the one? File. I think it is called something different. Material. Yeah, material icon theme. Yeah, this is it. Okay, I have this. I'm not going to use some maybe other kind of postman or so. So I'm basically going to do Thunder client. Yeah, okay. I'll use Go. Yeah, I think this is it. Install. Okay, Go is here. What do I need more? So basically, I have mostly this. Tokyo Night, Thunder Client, Material Go. I think we are good right now. Yeah, I think we are good. We just need one more thing, which is this one. Get extension, VS Code, sign up with Gmail. Hashmondo, this one. Okay, let's see. With the Codium, quick install, VS Studio Code, Codium install. Hope this works. Yeah, think this is it. Allow. So open, let's open. Let's directly do the configuration from here. What do I have to do? Okay, no. Okay, sign in with this. Okay, let's see. I have to do something. Open. Yeah, okay. So I'll basically need in VS Code command panel Control Shift P provide authentication token. Okay, command Shift P. Codium provides authentication token. What do I give the token? Where is the token? Codium token. What is this? Provide authentication token. Yeah, this is it. Provide authentication token. Where am I going to give the token? Is it not here? Uh, okay. Yeah, okay. Yeah, I think I configured. Okay. So basically just remove all this. Okay. I think my Codium is ready. I need Git. Oh, yeah, I need Git. Okay, so another thing is Git. I need to do my Git setup. Okay. So Git is a must. So downloads Windows 64 Windows setup. Download. Yeah, this will take a bit of time, but yeah, okay, that's okay. Yeah, so let's install. Next. Okay, back. Do I need anything else? No, I don't need more than this. So Vim is fine. Override the default branch name for new repositories. Yeah, I'll override actually. Main is fine. Next, git from the command line, also third-party software. It's git for git bash only. No, actually this is okay. Use bundled OpenSSH. Yeah, correct. Fine. Fast forward. Doesn't matter. Install. Yeah. Okay. Should be fine with this. And I need to do a GitHub setup. Connect Git with GitHub. I think you have to do a hmm 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 yeah, so you release note, no, launch git bash, correct. Go ahead, launch it. Get minus minus version, go minus minus version. Go is not a command. Okay, I don't know what happened, but yeah, okay, that's okay. Seems like the path is somewhere else, but yeah, we'll see. And now what I need is I have to connect the get bash. Okay, get config minus minus global user dot email shmundal 01 at the rate gmail.com. Get config minus minus global user dot name kingpin-ay. Yep, should be fine. Next, what is next? I have to actually connect. So let's create actually some. Let's try to copy some repository, maybe. Uh, let's take my Lancer project. Okay, so do I do SSH, not HTTPS? Let's do HTTPS. PWD. Okay, I need to create one folder, right? Do I have one? I actually don't. Okay, let's create one. Projects. Yeah, let's navigate to this. cd dot dot slash dot dot should be around C. Yeah, cd project ls, and if I do git clone, okay, I can't do, okay, I can't paste like this. Okay, repository, oh, double one. Okay, now it's okay. What happened? GitHub kingpin-ay https slash slash lancer. What happened? uh, where are this h is coming from? Cloning into lancer protocol http is not supported. Okay, now I have to do a setup, right? Protocol https is not supported. I know I'll face this. Supported. Right click, sadly whenever you do control V on terminal it adds hidden, oh, which is invalid. Okay, yeah, so get clone paste. Now let's do, yeah, it's working. So now what do I do? Yeah, ls. Yeah, so let's open code in here. Code dot. Let's make some changes. Citrus the author. Insert readme. Testing my GitHub connection. Okay, this will fail mostly. So, cd lancer ls git push git add dot git commit secondary commit. Let's see, git push. Oh, I have to do a push minus u. Okay, okay. Code. Okay, what happened? I don't know. Yep, pushed. I think it's pushed. Okay, so now I have a way to push and everything. Now what do I do is I basically go inside this and check my push. There should be a secondary commit. Yeah, okay, I think I'm sorted. So let's go to repository. I don't need git right now, but anyway, all of this is checked. So GitHub checked, code helper checked, editor checked, Golang checked. So I have to set up Golang one more time. So let's close this. Let's go to our Lancer. Let's delete and let's clean. Yeah, supposedly this should work. Done on the setup part. Let's delete this, don't need this. And Kodia maybe we need, but yeah, let's put in here product autocomplete. Yeah, this is a bit slow, but you have to take in consideration that this is likely like a good one. So what I'm gonna do is I'm gonna make another screen in here, which will basically VS Code and add a screen. VS Code, VS Code, and cross this. What I'll do is I'll make a display capture, no, window capture, window capture, VS Code, window. Okay, Visual Studio Code, automatic title. Yeah, okay, and on top of this I'll put one screen scene, will be screen for coding. Okay, yeah, now should be okay. And I need a couple of things in here. So firstly, like the goal and setup should be correct. Okay. Oh, and how to make git bash default edit default terminal in VS Code. Okay, so yeah, I got it. So basically default terminal, do I have terminal Okay, I actually don't have one. uh, let's configure actually. Integrated one, no. Extern. Can I do this? pwd and um, pwd. Okay, this does that. Okay, but yeah, I would prefer like git bash over everything. Custom terminal application to run on macOS, Linux, Windows. Okay, how do I do that? Nope, not this. So let me check actually. Uh, Select default profile and terminal in the top right corner, and you can choose your terminal from there. Okay, let's take select default profile, git bash. Now if I close, suppose I close, then I open up, what terminal do I get? Yeah, git bash. Nice. Yep. Okay, think I'm okay. Now let's start with go minus minus version. Yeah, go is also configured. Go. Okay, minus minus not version, like this. How do I check? Flag provided but not defined, minus version, box system version, print go version, go version. Okay, nice. 1.23.2. okay, clear. Okay, let's get started with this. Basically let me switch to the screen and go here. Let's go to example. Let's start with this hello project and let's create one. Maybe not from here. Okay, yeah, I made mistake. Get bash. This should be cd dot dot slash dot dot cd projects mkdir something. Let's make name it go learning, go underscore learning, cd go underscore learning, and let's open the code here. Okay, now I do a cross, I go here. Let's make one file maybe. What does it say? Our fast program will print the classic hello world message. Here is the full code, source code. To run the program, put the code in the hello world.go and use a go run. Sometime we will want to build our program into binaries. We can do this using go build. Okay, we can then execute the build binary directly. Now that we can run and build basic go program, let's run the okay. Let's try it out. Let's make a hello world.go. Okay, yeah, I don't want to see like this. Let's start with package main. So it is package main, right? Package main, import fmt. Fmt, I'm guessing the library containing all the IO streams, everything. So okay, import. Okay, my code editor is already started giving me this func main. Okay, so they use func main and fmt.print print will be greater. TLN. TLN. Hello world. World. Okay. So FMT is giving some error. Okay. So this should be wrapped in calibration, quotation. Okay. I save. Oh, one more thing I need, I think. Prettier should be a good. Prettier. Yeah. Code formatter. Let's download. Yeah. And yeah, extension enabled. Now if I save this, what do I do? It says to run the program, put the code in hello world. Use sometime we will want to build our. Okay. So basically I need the terminal. Okay, and what do I need? I need go run hello. Okay, so go run is the command. Hello world is the file name. Okay, so it runs. Nice. So I'm guessing like if we can create a binary, so this is basically a shorter way of debugging, like for developing part. Go run hello world go. Okay, and this is a go build. Okay, go build hello world.go. Okay, okay, it created a exe file for me. So yeah, let's run slash hello world. Okay, it runs. Sweet. Okay, let's delete this one and let's move ahead. Next, Go has various values types including strings, integer. Okay, I'll put this in the YouTube. Is it called? Yeah, this one. Go by example. Okay. Okay, I'll save anyway. I think I need the verification, but yeah, I'll do that later. Next, let's see. So next content is values, right? Let's go. So here it says Go has various values types including strings, integer, float, boolean, etc. Okay. Strings which can be added together with plus. Oh, so they allow string concatenation. Okay, integer and floats, boolean and boolean operators as you did expect. Okay, so basically what I do is I print a line. There is like a number addition. I don't know what it's called. Okay, it's called integers. 7 3. Okay, true, boolean and false. Okay, let's try fmt. So I have already seen like that. Okay, let's try from here with plus and put how are you, maybe. Yeah, and println. So let's remove everything and let's put 1 plus 1. So I'm doing a integer arithmetic. I'm facing. Okay, yeah, this should be like this. Okay, yeah, thank you. Hmm. না না
ভাত নষ্ট হয়ে গেছে, আমি খেতে পারলাম না।
ভালো আছে। Okay, how about float plus integer? Does it allow? 1.1, let's see. It's uh-huh. Oh, it does. Okay, it does allow, like, what about division? Go. Okay, let's run the run. Let's delete this. Okay, it does allow. Okay. So, like, cross things are allowed. Okay. I don't know if this considers as cross things, but yeah. Okay. Okay. So yeah, nothing much to here. Let's go to the next one. Okay. So now comes the variable. Okay.
রাতে দুটো সুজি খেয়েছিস?
Hmm. Uh, let's actually check. Let's take this. Okay, let's copy and like shit, let's do this. Okay. So what it does is, firstly, it's a string. It's a normal like string printing. Okay. Okay, you can assign values like this. So I'm thinking like this will be like a Python kind of thing, right? That's what I'm expecting it. But maybe, yeah. So this is like a Python. So you pass a maybe a function which gives like two values in return. So you can receive that like this. Okay, nice. And what does this comma do? Is it going to print in a different line because I'm using println? Okay, I have to see. Okay, d true. It prints like true in here mostly, I think. End. So what will be this int value? Let's run. Okay, initial comes in, 1 2 comes in, true true, 0. So this sets a initial value of 0. Okay, I didn't know. Okay, and what is this? What is this? Does it says anywhere what is this? Var declares one or more variables. Okay, you can declare multiple variables at once, which is this one. Good. Okay, go will infer the type of initialized variable. Okay, I can see that. So it infers like this one. We can also like, okay, and variable declared without a corresponding initialization, also zero value, for example the 0. Yeah, so there is always like a uh, initial state value. Okay, let's try this actually. I'm thinking this is called bold. Okay, so what is the default value of bool? Is it true? Is it false? Oh, okay. The default value of bool is false. Okay. And say, okay, this syntax is a shorthand for declaring initializing variable. Yes, so var if string is, in this case, this is syntax is only available inside functions. This syntax is only available inside functions. Okay. Oh, okay, okay. So what he is saying is, oh, we can denote like var outside of this. Okay. A equals to 10, but we cannot do this. Not, let's take B 20. Okay, this is not doable, but this is accepted. Okay, got it. So seems simple, at least right up till this point. Let's go to constants. So there are a lot of stuff in here. I'm expecting to go at least like a thorough round down. Okay, go supports constants and character string, boolean and numeric values. Okay, constant declares a constant value. Yeah, correct, that I know. Okay, so this is const, so just like JavaScript. Okay, const numeric constant type until it's given one. A numeric constant has no type given one. So can I do this in case of constant? Const a, and this will be integer. Is it going to by default take 0? No, it's throwing error. Okay, so basically in this case I have to give like an int and then a value 10. Yeah, Okay, so constant will take like initial declaration value. Okay. Now type until it's giving one, such as by explicit conversion. Okay. Okay, next for loop. I think this is for loop. Okay. Yeah. So this is for loop. Okay. How are they doing this for loop? For loop is pretty simple in here. They define one by that destructuring method, not giving any initial type. And the for loop is pretty simple also. It gives like a type, it updates it, but it's like you do a for with a while loop. So see, like the for syntax we use is like this in other languages. You initialize, you give a condition to break, and you update the variable. Simple. But now you can use the for in a while pattern also. Okay, seems good. Okay, you can also use break inside one. Okay, and you can use range. Nice. Let's once try. So what happens is this initialize to 1. So if I run this, I'll get the same values, right? So, oh, I didn't save. My bad. My bad. For now, we can enable the autosave, right? Where is that autosave? Autosave. Yeah, autosave. Okay. So this runs until it is 3, right? So this is the first loop. Second loop is 0 to 3. So it starts from 0, 1, 2, 3, up to 3. Okay. And okay, in the range part, the range is 3. Okay, what does I here means? What is range? What does range do in here? I initializing to int and the range is 3. What does it mean? So I is 0, 1, 2. So okay, I'm guessing what's happening in this case is it goes up to 3 from 0, but not 3. So this is something like this case. So you can shorthand this by doing this. Okay, seems nice. And break can be also applied in, and range can be used like this. Okay, nice. Next one, if else. Okay, so this is like a conditional statements part. Branching with if and else in Go is straightforward. Okay, let's see how straightforward this is. Okay, if like this, else is this, if is this, else is this. Oh, you use like a JavaScript syntax. Okay, now what is this? Hey, hold on. What is this? A statement can precede conditionals. Any variables declared in this statement are available in the current and all subsequent branches. Okay, note that you don't need parentheses around conditions in Go, but that braces are required. Hmm, hmm. Seems okay, but what is this? What does this do? Num is 9. Num is less than 0. So, mm, is negative. What is this doing actually? There is no ternary if in Go, so you will need to use a full if statement even for the basic conditions. Yeah, okay. Uh, okay, I can't see any chats. Hold on. Is there any chats? No, I don't know. Okay, maybe there isn't. Um, okay, so yeah, so if else is okay, I think, but yeah, this syntax is pretty much. Mama, mama, screen tapping. Okay, so seems like quite odd, but yeah, can be usable. Okay, not that bad. I Not that bad. Okay, so yeah, okay, let's try this out, only this one. Okay, save, run, go run, hello world, go. Hmm, 9 is one digit. Okay, 9 is one digit. What does it do? 9 num less than 0. So this is true, right? Num less than 0. So 9, no, this is not true. 9 is greater than 0. So basically this will not be running. This is what's running. Has multiple digits. Okay, got it. Like this is also quite self-explanatory. Next one, switch case. Okay, oh, we have the classic switch case. Okay, switch is pretty simple in my case. Okay. Okay, now this is nice. You can use it like this. Time now and hold on. What is this? Okay, what the heck is this? Switch case t dot hour tune. Okay, you don't pass a variable for the switch in here. That's odd. But you can do a check in the case. Okay, that's pretty rough. Okay, you can use a comma separated value in the default case in this sample example. Okay, switch case without an expression is an alternative way expressing if and logic. Oh yeah. So this is basically it's saying of if else. Here we also show how the cases work. Type switch case compares type instead of values. A type switch. Okay. Oh, okay. So they are like doing like this. Okay, you can like try a if else with. uh, okay, that's nice. Can do a type also. So you refer to type by I dot type. Don't know the type. So this should be coming as like type string. So t. Okay. So you can save the value of t, someone's type in t. Okay, quite nice. Let's go to array. Okay, what do I need from here actually? I need hello world base variables constant for else which arrays. Yeah, up till this point I need. Do I need slices and maps? I'll do, but yeah, functions I need multiple return values. Variadic variadic function. Okay, I need this part. Map slice I'll do with this. Closure, recursion, range over built-in types. Okay. Pointers. Okay, we have pointers, string and runes. I don't know what runes is, but yeah. Struct method interfaces enum struct embedding generic. Okay, there are like lot of things in here. I don't think I need all of them, but yeah. What is this non-blocking channel one? Select channel direction, channel sequence, channel. I'm thinking like this is something quite different. Okay, let's go by this. Okay, add a. Let's come down to add a. Okay, what do I do and add a? Okay, now this syntax is quite different. So let's take an example of this. Okay, it throws error directly. Okay, important. No, oh, so this is like something like a Rust. It throws error if I don't use println. Okay. So let's print the A. Can I print the A? Let's check. Oh yeah, I can. Okay, not bad. And all the values are initialized to integer initialized values. Okay, nice. Okay, I can like define this fourth value as maybe it will go to 100. So yeah, fourth value is 100. Length of A is what? Length is 5. Correct. This much I got. Now 5 integer. Oh, you can define the list like this also. Okay. Now that's quite nice. 1, 2, 3, 4, 5. Okay, nice one. So that declared like this. Okay, declaration B is what is this? 100. Okay, this is spread maybe. What is this? This is spread. Or is it like, I don't know. Oh yeah, he is assigning all the values to B. So yeah, this seems to be a spread. He initialized first, then he's changing the value. So 1, 2, 3, 4, 5. Currently done. Now he initialized again. 103. So I'm thinking this is the index 3. So it will go to before the last one. Yeah, correct. Nice. And then what is this? This is a loop. Oh, this is a two-dimensional. Okay, he assigned like two-dimensional like this. Okay, nice. So what just happened? Two refers to the rows. And no, two refers to. Oh, okay. So two basically is the dimension of the second one. So, so okay, see, like two columns, total two elements and three. This is like a classic C++. So yeah, seems nice. Next is like this. Oh, you can also define like this. Yeah, this is same. Okay, slices. Hmm. Go run slices.co. What does it do? I'm at slices. Okay. Methods, signals, exit. Okay. Hmm. Let's try the slice. So what is slice? Oh, you can do that. Wait, what? Can I do this? Hello. So if I do this and fmt print ln and do a dot 2 1, let's try 1 and do a this, what happens then? Okay, this gives 101. Why? What? 101. Hold on, what happened? This should come as E, but instead it gives 101. Okay, so what is this? 101. Okay, just a second. ASCII. I'm just thinking, but it might be true. I just forgot. Like 97 is A, I remember. 97 is A. 101 is E. Oh, okay. So this gives like a ASCII value. Okay. The heck is this? Okay. If I do a 2, L. L is basically what? I forgot actually. L, 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 L. 108. Yeah, it gives 108. Okay, so this is ASCII. Nice. Okay. And now, so here comes the ASCII operations. Okay. For a multi-dimensional data structure, the length of the slice, inner slice can vary. Okay, so this seems okay. Should be correct. Grid block in addition to the basic slices. Okay, seems nice. Next, maps. Okay, maps is something like dictionary in Python. It's suppose. Aim is like this. So basically, what I can put in here is varying, right? It varies. So what do I do from here? Okay, so slices can be put, you can make them like this, make map string integer. So the key is string and the integer is the values. So you put it like this, key as string and integer as values. Okay, nice. I don't think I'll need this that much, but yeah, suppose like we need this. Now the comes the code concepts. Okay, I need this. So okay. Oh, nice. You can do that. Oh, nice. ABC int. Okay, a int b int. You can put it like this also. You can call that. Okay, nice. Multiple return value. Let's see. You can. Oh, okay. When you return, you have to do it like this. If you return a multiple value. Nice. Okay, what is this function? Here's a function that will take an arbitrary number in int as argument. Okay, it took arbitrary number of integers. Oh, okay. So you can pass as many integers as you want. Okay, nice. Seems nice. For number range number, and then you go and do this sum 1 2 3, and whatever you give, it doesn't matter. It comes like this. Okay, and I'm hoping this is like a spread. Dot 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 spread. Okay. If you already have a multiple args in a slice, apply them to a verdict function using func slice this. Okay. Okay, so which is basically this one. Correct. Okay, nice. Next, closures. Okay, this is like a closure function. Now this I need, so I'll like apply this try. What happens in here? So they define a function int sequence, maybe ACQ. Okay, what happens is I is defined to 0. You call that, and it returns a function which will return integer, which will do a I plus plus and return the I. So basically whatever you do, you will get I like 1, right? That's what I'm guessing in here. So basically you define that. So next int is another function which you call. This will do is this will plus the I, so I will be now 1. Next time when you call, this same I should be changed. That's how closure works. So I'm just guessing, but let's see. So I'm guessing first time it will come 1 2 3, and then you like uh, assign this to a new one, and if you call this, this will be 1 again. 1 2 3 1 again. Okay, okay, 1 2 3 1 again. Yeah, correct. Nice closures. So closure is pretty simple like other languages also. This functions call itself until it reaches the base case. Okay, so this is like a recursion. Recursion is pretty simple. So yeah, Fibonacci number recursion. They did a Fibonacci number series recursion in here, and they return n minus 1 and n plus 1. So this is like a classical problem of dynamic programming, and yeah, so seems okay. Okay, now comes a range over built-in types. What does this mean? Okay, let's check. So where do we reach? Range over built-in types. Okay, we have a lot of things to cover. Let's see. So uh what is it doing? Package main fmt, correct. Num, so it assigns a list, or like in here it's called slices maybe. Yeah, and not slice, it's like a array. Okay, now array of integer 2 3 4, 3 numbers, sum equals to 0. For first one is empty. Num equals to ranges of num. Okay, so range actually assigns what? Range actually assigns whatever number you give up till that. Sum. So 2 plus 3 5 and 4 9 should be the one. This will return 9, correct, 9. For in the range of nums, same thing. If number is 3, print index I. What does I do? 3 is on the first index, so this should be, oh yeah, this returns 1, okay. Now it becoming a bit complex. Okay. Yeah, I think I'm getting message, but yeah, I can't see them. I don't know what's happening. Anyways, so yeah, so this is it. And what does this key KVS do? Huh. Okay. Yeah, just thinking I'm doing something wrong. Participants. Yeah, I am the one. Should not be wrong. Okay. KVS map string. So this makes a map of string to a string. Key will be string, A will be string. Okay. So A maps to apple, B maps to banana, and I'm hovering over the KVS. So K is basically key, I suppose. A is key, yeah, correct. Oh, you can do this, okay. Printf, oh, nice. So you have a printf, like a C. Hmm. C and go to the next line, you print again, okay. Seems nice. This is okay. KVS range, and I'm taking K in the range of KVS. So if I take range of KVS in here, KVS is this one. So only apple and banana should come. So if I print key, oh no no. If I range over a map, it takes the keys, not the. Now that's kind of hard. So let's do one thing. I just want to check this. Is it like running? Uh, like I suppose. So say I do this KVS, and I do this and this. What happens then? Yeah. Okay. Yeah, no. It's working like the same thing. Supposed to. Okay. Next. Oh yeah, I forget and I fucked up. Okay. So variable function, closures, recursion, built-in types, pointers. Oh, built-in types. Yeah, this is sorted, right? And range over go will do. I think this does index and this does like the character or like something different. Oh no. So this doesn't take the strings, right? I'm supposing this will give like the ASCII values. G is ASCII value. So yeah, see 103, 111. Oh no, correct. Yeah, I forget actually. So 0, 1 and ASCII values. So whenever you break a string, you get like ASCII values. I don't know if that is ASCII or Unicode. Unicode 8 table. Just a second. I think I might be wrong also. So let's check 111. Oh, there is no 111. Oh, this is also written in. Oh shit. Yeah. So this is written. Shit, man. I do basically did something wrong. Okay. Now coming to pointers. Okay, now this is like a huge jump. Let's be serious now. Pointers, yeah. How do you do pointers? So I assign I equals to 1. Okay, I is an integer. I assign a 1 in here. Okay, I print I, so this give me 1. Okay, correct. What is zero val is doing? Zero val is taking an integer. It's updating its this value to 0. Okay, if I do a zero val I and print I, yeah, this doesn't change because I am hoping this argument will be copied. So this changed the initial one but not the outer one. Okay, next is a string. Okay, now what does this 0 pointer do? Okay, he defined a variable called IPTR, which will be a star. Oh, so this is like that. Okay, asterisk int means the pointer of an integer value. Quite like C and C++. So, and then he sets, okay, he puts another asterisk before IPTR. So IPTR contains the pointer of I. So yeah, it goes, oh, dereferencing, okay, by asterisk. It's simple like C++, and it sets the value to 0. So I'm hoping this will, oh, and he passed like, oh, so this is like a pretty much C++. Sets the value to, it pass the address of this one, saves in here, updates this, returns, it becomes 0, and the pointer value is this. So now, nice. Okay, let's try this actually. I just want to try once. Should be good. It assigns to this pointer. So now if I run this again, it will be different. Oh no, it does again in the same path. Okay. Okay. How is it like pointing to the same one? Okay. So let's do a go build. Oh, okay. I have to assign the name. Hello, hello world.go. So now I'm hoping if I run hello world.exe, comes as the same one. How is the pointer always assigned to the same? Okay, I'm hoping like, oh, okay. So yeah. So yeah, I get it. What happened? If I run, so this is n- not the whole full thing, right? Yeah, okay. It assigns after like it deletes all this data after the program is run and it assigns the same thing. Okay, nice one. Next one. Okay, go by example string and runes. Okay, read only slice of bytes. Okay, a go string is a read only slice of bytes. Okay, the language and the standard. Okay, that's why the slice of bytes means like it saves like the ASCII values in that uh each byte. Okay, the language and the standard library treats strings specifically as encounters the text encoding is a util. Okay, so this is not like an ASCII. So this is like UTF-8. Yeah, correct. So that's why they say byte. Okay, nice. In other languages, strings are made of characters. In Go, the concept of string is called rune. Okay, it is an integer that represents an Unicode point. This Go blog post is a good introduction to topic. Okay. Yeah, correct. So I have already seen like this Unicode part of this. So you can now, yeah, just because they are using a UTF-8 and Unicode, this like becomes like quite ordinary to use like different things in here. You can like type in maybe Hindi, and I'm guessing this is like a word. I don't know what this means, but yeah, correct. This will all give like a number. Yeah, see, quite good. Yeah. Now that enables like a good one. Let's read through this. S is a string assigned to literal value of the word hello in the Thai language. Okay, so this is the Thai language and in hello. Okay, Go string literals are UTF-8 encoded text string. Since strings are equivalent to byte, so like a array of byte, this will produce the length of the raw byte stored within. Okay, so oh, okay. Now, okay. This changes most of the thing. Okay, so yeah, I got it. Like what happening now? Okay, so if I do this, what happens? Let's do this. So for me, I can see like there is 4 characters, right? But it says this line, since strings are equivalent to array of byte, this will produce the length of the raw byte stored within. So this is basically a byte, right? So if I can do like this, dot dot dot, and now type byte in here, what happens? Does this take this? Does it not? Invalid use of this array. Okay, I cannot do that. So can I do this? Constant type, byte is alias, Unicode is an conversion distinguished byte. Yeah, I cannot do that also. So yeah, but yeah, it says like this is it. Since strings are equivalent to byte arrays, this will produce the length of the raw bytes are stored. So I'm guessing this will not give like 4. Yeah, let's actually run. Yeah, it gives 18. See, like there are 18 bytes to define this 4 string. So that's why like now nice. That's nice. Okay. Might work in some cases, but might not work in some other cases also. So sometime I need like the only size. Oh, I'm hoping they are doing this by using this. Okay. So if I do this, what happens? And I have to import, right? So I don't need these functions. Delete. I can import, multi-import by this. Okay. So what do I do? Okay, my editor is suggesting this. I have to give a comma maybe. What happened? Oh, no commas. Okay. And this will be in the first bracket. Okay, not in the second one. So no commas either. Oh, okay, nice. If I do this now, what happens? It's delete. So I'm hoping this will give me 4, right? Rune count in string. So rune is basically this human readable something. Okay. So whatever amount of character you can see, this I suppose this print that. So I'm not sure, but let's run. Oh, it gives 6. How is this 6? Okay, indexing into the string produces the raw byte value each index. This loop generates the hex values of all the bytes that constitute the code points in S. Okay. Okay, so it's like dividing this, okay. But indexing into the string produces the raw byte values at each index. This is okay. To count how many runes are in. Oh, okay, okay. Yeah, I got it. Like how this is working. So it takes like character means like uh, something different characters also. So you have full stop in English, something like that. It takes that into consideration. Some other languages have some other kind of thing they put on their letters. So in Bengali, suppose like there's like which is called E. So you can put some Thai characters are represented. Okay. Hmm. Nice. Nice. So decode rune into string. Can decode that also. Okay, I don't know how much I will use this, but mostly yeah, I think this is pretty much necessary in cases of string manipulations. Quite good. Next one. Type person struct name string. Okay, so now we come to struct. You can use struct by this. Okay, this is a struct type has name. Okay, you have to use type to define a struct, not struct itself. Okay, yeah, I do that, and now I do a string person, and this returns a pointer to a person. Okay, I create a person like this. Okay, name like this. Okay, what if I do? Okay, let's copy this. Actually, I want to try something in here. If I do this, let's save. I do a person. Okay, person defined by Bob, and I'm guessing Bob goes to the name, age goes to the 20, and go order by. So if I do a no, let's not do. I understood like what this does, and you can assign this like this. So I will mostly use this one, not that the previous one. And then you can use define and pass a address. First will 3 will print quite good. Let's check. First one prints, okay. Alice is print. Fred 0 is print. In AND case, what is this ampersand does then? This doesn't give the address. Hold on. Let's check. Okay. If I do this and I put like this, what does it do? Okay, we'll print this. It does. Okay. And what does new person do? New person returns a pointer to a person. Okay, struct basically. Can I dereference a struct? Maybe. I don't know. Maybe possible. Hmm. Let's see. Yeah, I can dereference. Okay. Now that's nice. So if I do a dereferencing, I can do age and name. But if I don't do a dereferencing, I'm supposing, oh, I can still do name and okay. What is this? Oh, it does. Okay. Doesn't matter. Okay. Nice. Now what? It defines a new person. Age is a person of this. Age dot name. You can print as dot age. SP age. Okay. SP dot age equals to 51. You can do print dot age. So this 50 becomes 51 in here. Before that it doesn't change, but after that it changes. See, like I'm passing the address, but still I can change this. So yeah, pretty much the same kind of thing. And I can make in go struct like this. Okay, struct name is good. Rex true. Okay. Okay, nice. Seems nice. Print dog. Okay, so this prints Rex and true is good. Correct. Now what? Now what do I do? Structs are done. Methods, and after this I'm thinking of going to gen. Not this. Gen Golang. Yeah. So yeah, I mostly need this, and seems like the best one to use. Okay. Methods. What does methods do? So you define a struct like this, and then function which receives a pointer of rectangle. I suppose this is rectangle. Yo, hold on. What is it doing? So okay, this is not receiving any rectangle. So yeah, this is how you do a method. Okay. Go suppose method defend on struct types. Okay. This area method has a receiver type of. Okay. Method can be defined or either pointer or value receiver. Okay. So this is a value receiver. This is a pointer receiver. Correct. Here we call two methods defined for our struct. Okay. I call them. What happens? So this gives perimeter and this gives like an area. Okay. Quite nice. Okay. Interfaces. Okay, let's check interfaces. We're at interfaces. Then enum struct embedding. I don't know what this does, but generics I need. Range over iterators. I don't know. Error custom error. Go routines channel. I think I'll need up till this go routines. Okay, I need go routines and then I'll start implementing some basic APIs. Interface are named collection of method signature. Okay, so interface is a here is a basic interface for geometric shape. Okay, type. Oh, you have to mention interface in here. It's either a struct or either a type. Okay, Can I inherit? I don't know if I can, but yeah, let's see. Type a geometry interface which has like an area float 64 and area a perimeter float 64. Okay, type of rectangle. Here is a basic interface of geometry shape. For example, we'll implement this interface on rectangle and circle types. Okay, rect and circle types. So I do this interface on rect and circle type. How? I don't see any connection. I don't mention also in here somewhere. Takes R, but how do I? Okay, to implement an interface in Go, we just need to implement all the methods in the interface. Here we implemented geometry on rects. How did we made geometry on rect? I'm not understanding this, but yeah, okay. The implementation for circle struct. Okay, circle. If a variable has an interface type, then we can call methods that are in named interface. Here is a generic measure function taking advantage of this work on any geometry. Okay, measure. So this is in geometry. G geometry. Okay, G is basically calculated geometry. Okay, G dot area measures this. So I am making a rectangle. Correct. I'm making a circle and I'm measuring them. Right. But how does this connect with this? So, okay, let's try this actually. Hmm. If I do this, what happens? Okay, no, you know what? Actually, copy everything. If I do this, what happens? I have area and perimeter. Okay. Instead of struct, can I write geometry? Is that even possible or is that even valid? No, I cannot actually struct. Then how is this relates to this area and perimeter? Circle area perimeter. Okay. Oh, this measure function is what is it's doing mainly the all thing. Okay, so yeah, so this is kinda bad, but yeah, maybe we can do something with this interface thing. Okay, this interface is quite like odd how you do this interface. Okay, enumerate types. Enumerate are special cases of sum. Okay, so how do you create an enumeration? Oh, wow, nice. Quite a good of syntax this is. You do a var state name map this service. So you create like this. Okay, enumerate are special cases of some types. A enumerate is a type that has a fixed number of possible values, each with a distinct name. Go doesn't have a enum type as a distinct language feature, but enums are simple to implement using existing language idioms. Okay, so you do it like this. Okay, state idle servers. What is this? State idle. You map. Okay, so the key is the this one and string is the values. Okay, now you can how do you use them? I state. Okay, oh yeah, got it. Nice, quite nice. So S is a server state is a type of integer. Hmm. State idle is a server state which is integer. Huh, quite odd, but at the same time it's okay, I think. Yeah, nice. Struct embedding. What is the struct embedding? Base num int. You describe b base. This function is a method of this struct. Struct is seen. What is this base? Oh yeah, this is how like you implement a. So this is a number and this is a string. Now when you try to do a container, you have to give like a base string. Okay, okay, okay. Nice, nice, quite good. What is generics now in here? Okay, generics has a like lot of things. Yeah, and generics is all I'll need up till this point. Maybe generics and range over iteration. Errors, I need errors. Custom errors also I need. Okay, func. Slices of index. Okay, what is this syntax first of all? This is a difference sign, okay? And what is E? Hmm, quite odd. Let's run through this. Starting with version Go has added support for generics, also known as type parameter, okay? As an example of the generic function, slices index takes a slice of any comparable type and an element of that type and returns the index of the first occurrence of v in S or -1. Can compare values of this type with equals to and then not equals to also. So what are we doing? Slices index, okay? Takes a slice. I don't know what the different sign is doing, but yeah, suppose this is doing something and E is comparable in the range of I, which is basically taking S into consideration. If v equals to S of I, then return I, otherwise return -1. Hmm, seems okay. And if I do a list t any, oh, any is the one that does like an hmm, what does this t do? How do you even call them? Foo bar zoo, okay. Slices index ace and zoo. So if I pass ace in here, this is basically a string foo bar zoo, and pass e in here. So that will print for 1, right? I, it will print like an 1, 2, 3, 3. Oh, sorry, 1, 2, 3, 0, 1, 2. Yeah, correct, 2. Okay, seems okay, but yeah, I don't know if I understood completely well on this. Starting version on Go has added support for iterators, which lets you range over pretty much anything. Okay, so let's look at the list of items. Previous example again. In that example, we had an all elements method that returns a slice of all elements in the list. With Go iterator, we can do it better, as shown below. Okay, so I'm hoping this is the push function. This is the all function. So iterator is doing this. So iter is the package. I think this is packages. Okay, package, and you package over them, and then you do this iterator list int of this empty list push 10 13 23, and then collect all. So all is basically going to return everything. Yeah, all is giving everything. So now you do all the operations, correct? Let's go to error. Go, it's idiomatic to communicate errors via an explicit separate return value. Okay. Hmm. Hmm. Errors. Okay, I can input errors. Okay. Nice syntax by the way. Error is the second value that I pass. Okay. Arg equals to 42 can't work with 42. error new. So you create a new error. Okay, what does it do actually? Let's, I want to handle the errors, that's all. So if I do this, okay, let's analyze through this. Hmm. So what happened here? Firstly, I do a for loop. Index will be 0. I mean, I'm not taking any index into consideration. I only take the values. So range will give me 7 and 42. Okay, one after another. If I do a if r comma e equals to f of I. Now what does f do? If I pass 7 in here, just check 7 equals to 42. No, so it returns uh 7 plus 3 10 plus nil. Okay, also null is here, nil. Okay, and what does it do? It checks is not equals to nil. So okay, so you need to have all this criteria, right? If this is this, r and e equals to f of I, so r gets the 10 and e gets nil. It will fail for 45 and it will pass for work for 10. So yeah, simply it's doing f work for 10 and 42 can't work for 42. Okay, so this doesn't add the 3. So okay, correct. So yeah, nice kind of usage of errors. And now here this is custom errors. Okay, arg error. Okay, error will take one argument, a integer and a message. Okay, custom errors. And now we go to go routine. What does go routine do? Go routine is a lightweight thread of execution. Okay, so here comes the thread. Now let's see. A go routine is a lightweight thread of execution. Okay, suppose we have a function called f of s. Here's how we did call that in usual way, running it synchronously. Okay, you run a function of f of s synchronously and you print them. Okay, so it takes like a string and it starts iterating over that. So start from I, it should be less than 3. So it prints like 0 1 2 and I plus plus. So whatever strings I give, it will print the first 3. And okay, from is not doing anything in here. Okay, anyways, so it put the from and the index. Okay, now what I do is I call this by f direct. To invoke this function in go routine, use go. This new go routine will execute concurrently with the calling one. Okay, go func message string. And what am I doing? I'm giving go. Okay, going fmt print message time slip seconds. You can also start a go routine for an asynchronous function. So I'm hoping so. So see, like if I have to run a thread for one maybe one API call, I do a go function call, right? Hmm. Seems okay. So let's try this out once. Let's check the thread is as good as Java or not. Hmm. Now this is interesting. Okay. If I do a hello go world, what happened? So this first one prints. So I pass a direct in here. So it prints direct 0 1 2. So this comes from this first one. If I don't do a go F1, what is going on here? So it prints the message, right? So going is print first, okay. After this going is, oh, because this is running as asynchronously. And now if I pass go routine in here, this is printing as 1 to Z. And then done. What is second? Oh yeah, it's wait for like 1 second and then stops. Okay. So basically if I hit run again, so it might happen that go routine comes first and going goes down. Yeah, correct. And this odd will be changing. This time this comes first. Okay. Going first. Okay, okay, got it. Nice, nice. Now this will come in handy. Hmm. Go by example. Channel are the pipes that connect concurrent go routines. You can send values into channels from one go routine and receive those values into another go routine. Oh, okay. Now, yeah, now this is okay. Chan is a string. What does it do? Create a new channel with make chan val type. Okay, channels are tied by the values they convey. Okay, so I make a chan means channel in here, and this will give like an string, right? Okay, so I call a func. I don't know what this func do. This prints a message ping, and I'm passing nothing in here, so it will print ping. And what is this doing? Ping, okay. What does it do? Okay. Convey. Send a value into a channel using the channel syntax. Okay. So you pass a value by doing this channel. Okay. So I pass a value in this channel ping. Send ping to the message channel we made above from a new go routine. Okay. I made a go routine and I call it. And when I'm calling this, I pass a ping. Okay. The channel syntax receives a value from the channel. Here we will receive the ping message we sent above and print it out. Okay. When we run the program, ping message is successfully passed from one go routine to another via our channel. So ping is passed here in message, so I'm not saving it directly. Message contains this ping, but now I can pass this in this. Oh, okay, okay, so this is how you do it. Okay, this is like an like definition of an variable. So you define that in outside of this context. Okay. By default, sends receives block until both sender and receiver are ready. Okay. When we run the program, by default, sends and receives block until the both sender and receiver are ready. This property allowed us to wait at the end of our program for the ping message without having to use any other synchronization. Okay, this is nice. Okay, now this looks awesome. Go routines. Hooray. Nice. Now what? Channel buffering. I don't know if I do need this, but yeah. By default, channels are unbuffed, meaning that they will only accept sends if there is a corresponding receive. So when you send to a channel, you use this after the channel name, and when you receive, you use this from channel. So to channel from channel. Correct. Corresponding ready to receive and send values buffered channel accept a limited number of values without a corresponding receiver for those values. Oh, okay. So yeah, now what you do is if you do this buffered channel, so I'm thinking buffered will print first because the channel received buffered first and then channel because channel received. Oh, okay. So this is how you pass multiple values. So you can make like a queue for this. Nice. Hmm. Do I need after this? Channel synchronization, channel direction. I might not need this. Workers pool, ticker timer. So maybe up after, like, I have completed up till this channel buffering. Does this give like how much I do I need? Unless, should example assume the latest major update and may use new language feature, try to upgrade. Okay, okay. So I still have this many complex things to do. Non-blocking channel operation, time, epoch, time formatting, parsing, number parsing. Oh, I don't know how to parse number yet. Okay, we'll see. Directories, embed directories, logging, HTTP client, HTTP server, spawning processes, existing processes, embedding directive. So I do want to try like the logging one and HTTP client and server from here. I need this too. Write to a file, read from a file I also need, but yeah, we'll see about that. Go by example, logging. The Go standard library provides straightforward tools for outputting logs from Go programs with the log package for free from output and logs slash log. Okay. Go standard library provides straightforward tools for outputting log from Go programs with the log packages. Uh, Log packages for free from output and the logs log package for structured output. Okay. Simply invoking function like println from the log packages uses standard logger, which is already pre-configured for reasonable logging output of OS standard error. Okay, additional methods like fatal or panic will exit the program after logging. Okay, so how does this work? Println, if I do a log.println, what this does is it prints like then log standard logger. Okay, nice. And after I do a set flag, lst flag, lstd flags, and uh, or I think this is like an or, so it's like a TypeScript variation of string or null. Log lm microsecond print with micro, so you can print with microseconds also. And short file, short file lcd flag, so you save one flag and you put like this flag. Okay, now quite nice of this from buffed line this and this. Okay, and you can structure query. So I'm not going to use this structure too much of this, but yeah, logs is nice. So this log itself is quite nice. This is all like a standard variation will need logger. So okay, and what about server and client? Let's see. Now we're going to a server client territory. Okay, writing a basic HTTP server is easy using net HTTP package. Okay, you import the net HTTP package. So let's take into consideration of this. Okay, let's make an server dot go. Okay, right, I put this all, I save in hello.main. Oh, what is happening? Oh, we can't have do two hello main packages, right? So let's make this secondary. So I'm thinking this is happening because of we are in the same package scope. So yeah, main only have one. Okay, so I'll have this one. And now what is it actually doing? So I import net HTTP. Okay, I write a function which says hello, which receives an HTTP dot response writer. Okay, and req, which receives an HTTP dot request pointer. Okay, and it prints printf. What is this printf? What does this print do? If I run this, Okay, I can do that. Nice. So let's see. Let's see. Let's not go too much ahead, but yeah, let's see. So W is basically the response, right? What is the response actually returning? It gives nothing in here, but what is this F printf? IO writer and format string. Fprintf formats according to the format specifier and writes to W. It returns it returns the number of bytes written and any write error encountered. Okay, so there is an error statement also in this. So basically what I'm doing is I'm writing in my response this hello text. Okay, quite good. So if I do a hello, then this runs. Okay, header is doing response writer correct request and this. So it takes what? Name and header is restructured from the range of request header. Okay, and and inside that I'm running a loop again. So this is destructuring the header, okay, and printing out that, okay. So okay, how do I specify a okay. So this is like a client server model. Let's see. So if I now run server.go, this prints nothing, right? Now it asks for permission, I give that. If I open up another git bash, not let's open in here itself, git bash, and I do a curl to what? Local host maybe, yeah. So local host, what is my point? 8090, okay, 8090 slash if I do an hello, it prints hello, okay. If I do a headers user agent curl 8.10.1 and it accepts some variable. Oh, okay, nice. Okay, seems nice. So we do a http dot handle function if I hit in this point, http handle function if I hit in this point, and listen and serve. So it listens to this and serve. So thinking the second one is an error. Oh, okay, this is an error handler feed like nice. So if I down this should not work. Simple, right? Yeah, it failed. Okay, nice, quite nice. Yeah, I think we are kind of ready to go for an full-fledged Gin framework setup. So let's make the setup in here. Package will be main, and okay, what did I do? Oh no, main will be it, and import fmt and this. Okay, now let's go to Gin. Okay, and introduction. Gin is a web framework Golang feature up to 40 times faster thanks to HTTP router written. It features a maritime like API with much better performance. Okay, nice, quite good. I don't know about this. Yeah, crash free. Jin can catch a panic occur during HTTP request and recover it. This way, server will always be available. As an example, it is also possible to report this panic to Sentry. Oh yeah, we can use Sentry. Okay. So yeah. Anyway, Sentry, Winston, whatever. JSON validation routes, grouping, error management, rendering built-in. Okay, extendable. So I just need like a JWT quite extension in this. That way, like it will be better. Hmm. So what you do is you do a get go get minus u gin. Oh, so you pass like an GitHub link, okay? Latest or install this, download and install this, or install this, import go tin, okay. Optional import record, for example, if you const constant such as status, okay. Oh yeah, we can pass like an status okay and all this. Okay, nice. create a project folder and cd inside that. Call main.go, run main.go, run your project. Okay, touch example. So you do set up a gin like this. You do a get request like this. Ping. Function will receive a gene context. C.json 200 gene h. H means I think header, like the receiving text. And this is on this. Okay, ping browser. Okay, nice. So if I do this, this should not work, right? Because I don't have this. So what I do is I do a go get minus u and then this URL. In the current directory. Oh, I need a go mod file. Okay. So uh, how do I do a project setup in Git? Okay, go project setup. How to write go code? What the heck is this? Make directory. Okay, I go in it. Oh, I do that like this. Go mod init example slash user slash alternately clone it if it's already exist in the version control. Go get init example slash user slash helper. Hello. Okay. So it means go creating a new go mod module this. First choose a module path. We'll use example user slash hello and create a go mod file that declares it. So I need a in here. So go what do I do? Go mod init. Okay. If I do okay. No. Go mod init. Say like example kingpin ay dot try get slash trial. If I do this, oh, it creates. So okay, let's check this one. So module is this. Okay, I got it. Okay, so now I can run that go get gin. If I do that, I'm hoping this will add to this, right? That at least my understanding is telling me this. I don't know what will happen, but yeah, let's see. Oh, it's downloading quite a lot of things. What is it downloading? It's downloading crypto, text, net, protobuf, syscrypt. Okay, tons of thing, but I don't know. Like, Jin, how much does it download actually? It says like it's 4 times faster, but yeah, takes a lot of packages though. CPU ID is okay. Arch loader. Okay, nice. Okay, so this added this all of this. If I do a save, what happens? It's still not like, let's close this. Let's open up. Yeah, now it's gone. So go some. So it does like an oh, okay, nice. Git go mod init is the command to set up project, and this is okay. So I did like in this. So I copied this example. What does it do? This defaults on server by gene.default. It do a gate. So I set up an endpoint in here. r.get, which will be a ping. Function will be c star gin.context. Correct. So I'm hoping this context is like all the things regarding all the request values that is coming. So now it sends back an JSON with a gin h context message pong. Okay. Nice. So let's run this once. Go go run hello world.go. So it runs now. I have a okay gin debug get ping. I have a default debugger with gin. Okay, nice. So I don't know how to off that, but yeah, I think that will be interesting. Gin default context, add engine gin, build JSON, port user, run 8000. So I can pass port like this also. Okay, okay, that's nice. So now if I do a curl, okay, curl localhost, what is the 8080 slash ping. It gives me a pong response, and oh okay, now nice, it's like highlight this how much second it takes. Nice. So let's build another get endpoint. Ping test. In here let give like a complex message. So yeah, they said like I can also use uh net HTTP, correct? If I do an instead of 2000 this HTTP dot status, I don't know why this is throwing error, but yeah, okay, this is not throwing an error. Okay, status okay. Yeah, I'm hoping this will give me an 200 and the message will not be pong. Let's pass some random bullshit in here, maybe a couple of times. So now if I do the same thing with this new endpoint test, will it work? No, it will not, because oh, I didn't do like an reset of this, that's why. Now that's nice. Okay, if I do a run, I allow. Now if I do this gives okay, nice, seems nice. And how do I know actually when error is happening? I don't want benchmarks feature, zero allocation router not needed, deployment. Yeah. Projects can be deployed easily on any cloud provider. Cohab is a developer friendly serverless platform to deploy apps globally with Git based deployment, TLC encryption. Let's see. No, actually I don't want to do that. I am want to turn off the logger, or like yeah, I'm guessing it does it like this. So if you do a go build hello world, it builds that. Now if you do a hello world exe, that starts the server, and this is how you do a what is it called, the deployment post. So if I do a same thing, it gives an instantaneous responses. Okay, now that's nice. So let's implement couple of more routes. So can I do an r dot post? Yeah, I have that. Let's give a receive data endpoint. This will be on func. Okay, I'm hoping this is a okay gin context func. Okay, now what do I receive? How do I receive stuff from here? Okay, so let's say I want to receive an user ID. How do I receive that? Ctx dot uh do we have body? Request dot body. Okay, and what does this body do? Okay, let's check an examples. Post request, post String or post request, where is query and post from. Okay, so I do it by id is query. Okay, c dot query, what is this doing? Query id. Oh, this is how I receive like an. Okay, let's try actually. Let's remove everything. Let's put a query and I do a query of this user ID. Now I print the user ID first and let's print it with logs. Log, and instead of fmt let's do a log. Log println user ID, and then I give back an data c.json http standard okay gin each context gin header. And inside of this, so say suppose I do some calculation and I'm giving like a score of some user. So say I give a score of 20, 22 maybe, right? So now what happens? So this will be ctx, yeah, that I know. And if I do this, let's one more time build this, because I'm thinking like build is the better version of doing it like in regular way. Hello world exe. It starts, it listens. Now let's do an actual post data. So new request http, not www, it will be localhost 8080. Endpoint will be received data. It will be a post point, and let's body, let's give a context. So user ID is the ID. I give a user ID of 20. So what happens if I send? I get a score of 22, which I passed, right? Now, can I, is it possible to do it like this? Let's try. Var equals to string. Can I do like this? Is it doable? Okay, this is not printing the user ID, is it? It is not actually. It prints the time, but it doesn't print the. Okay, why is that? User ID is 20, but I'm not accessing the user ID. It doesn't print anything in here at all. Why is that? Let's start with fmt maybe. What happened? Go build. Okay, what is happening here? I'm quite confused. Why didn't it print anything? Okay, there is nothing. User ID is not it. User ID is not it. Okay. Then how do I pass data? This is not it. Custom log files. Okay. No, I don't need this. Let's check something. Gin framework post endpoint. Okay, let's take an example. They have given like an one example. So home path, you do and get service. Okay. So it says it makes a type of album which has an ID, title, artist, and price. Okay, and it makes a dummy data. So ID this and this, then this. Fine. Now write code beneath the struct code you add in the preceding section. Yeah, so this is basically they are defining this function out of everything. Okay, so you receive one gin context, indented JSON, you return an album. So yeah, it does it like this. Okay, fine, I got it. So it receives a gin context and it gives back and data. Okay, now what do I do? How do I do an post one? Net HTTP. Okay, added gin, and then post album. Okay, var album, new album equals to album, a new album. Okay, if error, so bind JSON is coming from new album, and context bind JSON is checking if there is an error or not. If there is no error, call bind JSON to bind the received JSON to new album. Okay, now how do I call this endpoint? Using curl, so include header like this, application.json, post like this, and then receive like this. So what are they doing? So they are checking if there is any error or not in the C bind JSON, and they are receiving only the error. If there is no error, then append new album. What did it do? Append new album, C indented JSON, and it returns back the JSON. What? Change your main function to include the post route. Okay, I got it, but what am I posting here? I'm not getting it. I didn't receive anything from here. New album is passed, new album is created in here, which is completely outside the context. Okay, okay, run the code. Let's see. HTTP album slash. Okay. I pass an ID for title, modern sound. Yeah, and what did it do? The command should display headers of the JSON and added album. Okay, this is the header and this is the added album. How did it go to new album? That's what I'm not understanding. So c.bind JSON, I'm passing a this. Okay, so this bind JSON is basically dumping some values inside some variables. Okay, so this should be workable if I put like this. This is not context query, so let's not do that. Let's do a so I'm passing a user ID, correct? So I want to receive an integer, so I put a int and then I do a if err, which I'll get from bind ctx bind some bind JSON. I think this is the function, and in here I'll pass like the actual what is it called, pointer of that user variable. This will write that in that. Okay, nice. Err not equals to nil, then I'll do a JSON bad request. Will send an error and error dot error. Okay, seems nice. And after I do this, this should be here, right? Either I do a log or something else, it doesn't matter. Log. If I do this, remove maybe the fmt, save, receive, save. I do have a log and everything in here. So let's print also the user ID is and space and then comma, and let's close our current running server. Let's create another one and let's run the server, right? Okay, I think my bitrate is dropping. Something happened in between, but yeah, anyways. So yeah, that's not the concern. Okay, I'm up and running. So now if I do a send, okay, this gives me like an error. And okay, received data has an error. The user ID is 0. Headers were already written. Wanted to override status code 400 with 200. Something happened. What? How am I going to receive a value? So bind JSON is the function I've seen. Bind JSON, yeah, correct. I do that. I put that error not equals to nil. Then return. Oh, I cannot go after this return. I have to close the whole thing. This comes in, and I'm guessing this came in here. Warning, headers were already written. Okay. Something I'm doing is quite wrong in here. Let's see. How did they write that in a? How come this works in here, but that is not working? Quite odd. Acha, okay. If I do this, will it work? Type struct, and before the struct, receive user ID. If I do this, user ID int. Okay, no. User ID int. If I do this, what will happen? Now let's do a data. It will not be an int, it will be of type receive user data. So now I'm passing data instead of this, correct? And I'm checking for the nil. So I'm going to update that in data.user ID. I save, I close the terminal, go run hello world.go, I restart the server, allow access. Now if I do this, still gives me a 0. Why though? Does it not read the data, or what happened? Bind JSON. So let's check here. What do I actually have? Accepted error params request writer keys. Does this keys do? Keys operation cannot call non-function CTS keys values type string to any. Keys is a key value pair exclusive for context for each request. Is that so? Then I don't need the type. Shit, I didn't need even that. Okay, user ID not equals to nil. CTX. I have to put a int in here, okay, and do a user, instead of doing it in here, let's do it in here. Ctx dot, okay, get your iter keys, user id int. What? So let's not put the int in here. Cannot use ctx key map index expression of type any as int value is variable declaration need type. Okay, okay. So let's not change that. Let's typecast this to any. So now, does this give like an error? No, this is not a function, so that's why it's not giving any error. So let's print that. Cancel out. Let's run the server again. Allow access. Okay, this is coming as nil. Will this help? No, I'm passing as any also, so user ID should be fine. What is it that I'm not doing? Gen framework post endpoint, let's see. Tutorial create post request. Should bind JSON. They're creating content like that. Okay, post content dot. Okay. How to receive data in Gen endpoint. Pull data from an API. No, 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 no. This is completely wrong. I'm going in a. No, that's not it. Uh, Gen co endpoint. Huh. Hmm. What is it doing? Gin context. Okay, new user. How do you get this user? So you create a new user, you define that struct, okay, and now you do an error bind JSON user. Okay, you expect the error. If this is nil, then print string this failed in this error, gtx return or something else. Okay, okay. Oh, in here they are not giving like an. Okay, that might be it. Let's see. Data equals to receive user data. Instead of ctx key, I'm going to do a bind JSON. So passing this, I'll pass directly this value, and now cancel, run again, allow access. This throws an error. What is the error? JSON unmarshal non-pointer main dot receiver user dot id. Okay, so what am I going to do? user underscore ID. I can't seem to find the. Okay. They do the same GTX bind JSON text in this log error and then do something with the user. Server Gene cannot handle routine before action JSON request from Axios. What request should be sent from application access from encoded. My decision in view project use view resource instead of Axios post. This HTTP post with option view. Receive body in a Gin framework Golang get request body. So I need a request body. If you only want to pass the request body JSON registers value, well, I don't think this is it. Get raw data, or you can use get raw data function. Want to get JSON body like other framework like Express Node and do the following. Read all. Oh, it have everything on that. Okay, my bad. I'm doing constantly wrong thing in here, but yeah. User ID should be a user underscore ID. This will be an int. So request dot body. Body is the request body for client user. Nil body means that the request has no body, such as get request. The HTTP transport is responsible for calling close method for the server request. Okay, seems nice. I don't think I need this, so I can directly do an user under ID equals to. No, let's do that before this. Equals to ctx dot request dot body. What does it give? IO reader. Okay, so this gives an IO reader. So how are the passing this? IO out till read all. Okay. Okay, something is going on here. But let's do any for now. And pass user data directly in here. Save, cancel out, redo. Allow access. Now if I do a send, oh, this gives an 200. Okay, so this gives a very long thing. I don't know what this is, but yeah. Send but what if you want to access JSON values from the request body? Here is the solution. IO util dot read all. Okay, you can directly print the string. Okay. JSON dot unmarshal. I can do that. Okay. Seems nice. Okay, nice. Looks awesome. Yeah, I think that will be it for today. We'll learn like a lot of things. Yeah, and the next day we'll start implementing like all the endpoints and all. Yep. So that is it.